I hope you guys know the basics. We'll be designing a simple line sketch of the go-kart. For this go-kart, we'll be using inches pound second measurements because it's easy because all our measurements were done using inches and it will be easier to make the pipes also. You guys can hear, right? Okay. We shall see. There are three planes. I hope all of you guys know this. There are three planes: the front plane, top plane, and the right plane. Now, since we are going to build our basic chassis, it will mostly be on the top plane, which we will consider as ground. Now, uh, we shall. You right click on it. You can sketch on it. That's how you enter the sketch mode in SolidWorks. You right click on whichever plane you want to sketch upon, and you get an option where you can sketch. We shall get a basic structure just using the triangle, rectangle. It will be a center rectangle. You can use any rectangle. There are multiple options. Now, our the first thing we decide is we normally do this design based on the measurements which we get from by measuring a person, meaning the driver. It is always based on the driver. The design of the chassis is mostly based on the driver. No, we after getting these certain measurements, we it is normally done by the driver will sit on the floor in our lab itself, and we use a duct tape to get all the members. Yeah, you would have seen it in the lab also. It was on the ground itself. Yeah. There, by using that, we get the track width and the wheelbase length. Now, track width is the distance between the front axle and the rear axle, and the wheelbase is the distance between two wheels of the front axle or the rear axles. The same thing. Anyways. Now, we'll define the wheelbase first. Wheelbase, we'll take it approximately as 35 inches. And the track width, we'll take it around 40 inches. Sorry, this 40 inches is the wheelbase. Wheelbase is the distance between the rear axle and the front axle. And the track width is the distance between two wheels. Yeah. Now, this is the basic dimensions of the go kart. We shall just use this as a reference. So we select the whole thing and make it for construction. Okay. Now we can start our chassis design. We shall first give this, which the shaft. We shall consider this bold line as the shaft and make our designs. Yeah. Do you have any doubt, Anurag?
No, no, no.
Okay. Okay. The, now we shall this will be the place where the seat will be located. Just before the front axle, the front axle will be located on this line. Yeah, this part of the chassis will be parallel to the ground, so we won't be taking any elevations, and it's just straight parallel to the ground. Correct. Now we shall How will approximate? This is not the diamond accurate design of the chassis. I'm going to teach you the basic concept of it. Okay. Now we shall take this approximately to be 30 inches. This is mainly to accommodate the seat and a few more structural members to get additional strength. This will be the space, and I'll add two more members. Hmm. Now I'll give this length as 15. The distance between the side and the structural member, I'll give it as around 12 inches. The other side also, it will be 12 inches. Hmm. Yeah. Now we'll, yeah, 1 minute, guys, 1 minute. Yeah, we'll get back to it. Actually, there was a small mistake in this, anyways. I'll do this again, not the whole thing, just the this part. Yeah, this was correct. After that, this is the chassis. Sorry, rear axle, the shaft. Now the chassis won't include this. We don't include this in the chassis. We started just a bit before the rear axle to accommodate the motor and everything else. The firewall, battery, controller, everything, brakes. We'll start it from a distance of 8 inches. Then we'll give the seat part, allowance for the seat. This will be 20. The structural members, this will be 12 inches. These things, I'm using mouse directly here. You don't need to use those. You get those options over here. Line, this is for line, this is for circle, this is spline, which you won't be using. This is tangent, this is rectangle, this is the ellipse. These are fillets. Fillets are used to keep, these are sharp edges to make them. eh, we give a fillet so that they get rounded. I'll give a radius of rounded. That is what fillet means. Polygon. There are different polygons. You can give 6, 8. 4 is a square. You guys know. 10 is 10. And then these are slots. You would have seen in many mounts. They normally don't give just a circle such that the screw fits. They give slots like this so that you can adjust it. You can move it vertically up or down or even horizontally, so that the motor or anything you want to mount can be put accurately. I'll be using underline for an structural member. Hmm. This is the part where this chassis, the seat will be. Yes. Now we'll go where the battery, the controller, the motor, and the rear bumper will be there. This will be the rear bumper. This line will be the rear bumper. I'll I'll see. This is the midpoint of this line. This might not actually be in line with the origin. To make that in line with the origin, just click on the origin. With control, click on the no. Don't click on the line. Go near the line wherever you expect the center to be. You'll get a square point. With control, click the square point only. You'll get multiple options here: horizontal, vertical, coincident, and fix. We normally don't use fix. Vertical, the line will become horizontal such that the points will be vertical to each other. Coincident, it means that these both points will be in the same line. Then horizontal, we will be using horizontal option here. I'll give this a distance of 16 inches. And a few more not structural members. You need to connect the rear bumper and the shaft, right? That will be this. I'll add a few relations to make my design easier. I'll uh, I'll select both this and this line using control and make them equal. Also this line and this line and make them equal. Now I'll given the dimension for these members as 10 inches and an angle for these. If you click two lines at once, you get the angle. I'll give them around 35 degrees. Add another structural member. Uh, this will be the back end of the motor, back end of the chassis. I didn't give the this lines dimension. This will be 45 inches. Now, as for the front end, for the axle to be for in the back side, the axle will rest on two bearings. So you don't need to worry about axle, axle hitting the motor or coming in contact with the chassis. Axle coming in contact with the chassis. But for the rear, for the front part of the go-kart, yeah, for the front part of the go-kart, there are multiple parts that need to be mounted over here. One is the steering, the pitman's triangle, then the accelerator, the brake, brake, and the stud axles. All these. Normally, all these are the stud axles, stud axles, and the pitman triangle. Both of these are in one plane. That will normally be the ground, the in plane, in line with the chassis. 1 minute, please. since the stub axles and the pitman triangle and the rods will be in line with this chassis, we need to elevate the frontal portion a little bit. We'll do that by using 3D sketching. For that, we'll have to get out of the first sketching. You get that option there. These are the options for that. You get out of the sketching and go to sketch. Under the sketch, in the drop down, you get 3D sketching. 3D sketching is not that convenient, but we can use it. 1 minute, please. 1 minute. Yeah, there was an issue with the mouse, so got in that one. Yeah, as I was saying, those uh, those parts of the steering will be in line with this chassis member. So we'll give a light elevation to the chassis. That curvature will be there. We'll do that using 3D sketching. 3D sketching is not that convenient, but we have no other choice. For these, instead of using multiple planes, see, we did this sketch on the top plane. We can get as many planes as we want in whichever direction we want. Instead of doing that, we'll use 3D sketching because few times getting too many planes is also very confusing and not so friendly, user friendly. So we'll be using 3D sketching now. No, we'll again take a line. See, you get different access when you try to click. You need to. Hmm. it's in the downward direction. We'll get it to the top. You can always drag or any when it's not completely defined. If it's completely defined, you will get the line won't be in blue color. See here, all the lines are in black color. It means that it is completely defined and you can't move any line in any direction or increase the length. But as for the other one, yeah, this one, the line is in blue color. It means it's underdefined. Sometimes you just can't define it. I mean, you can define it, but it will be too hectic to do it. So you can use an option called fix, but we'll be defining it for now. Before we do this, I'll delete this 3D sketching once again. I'll delete it. I'll first take a plane, reference plane. It will be present in the features. This is the reference plane. We want the you can drop down this. This is the tree. You want the reference plane on the front axis. Since this is where we need the curvature to be, we'll select this. We want the plane to be a right plane, and the second reference is it is on this line. Make sure that this is selected as parallel and not perpendicular. And you can just get the plane. Now you'll get a plane. You can right click on the plane and select sketch. We'll make a rectangle again. Not a center one this time. Corner rectangle. And we'll make this rectangle construction rectangle. This is just for our convenience so that we'll get a approximate height. The height, how much you want it to increase. This for construction. This is 3 in, not 3 inside, that's a bit much. 1.5 inside. I'll make these points coincident. This was 35 inches. Yeah, I'll get out of the sketch and again do 3D sketching. From this point, using a line from this point to this point, or instead of that, I'll do from this point to this line, that's all. And I'll give a distance of this around 3.5 inches. See, now that blue line becomes a black line. It means that it is fully defined. Now again, we'll go back to, this is one thing. Now we want this to come down again. This is where the axle will fit. Now we want this to come down again and touch the, get into the same plane as the before part of the chassis. For that, we'll be taking and we'll get out of the 3D sketch, make another small design on top plane again. Now this will be in a different sketch than the first sketching which you made. So again, we'll select top plane, get into sketching mode, and draw in the rectangle. No, A line is enough this time. You can get a reference line by just hovering your mouse across on this line. Got it? We'll just make this and this equal. No, 35. I'll give this the distance of right. I'll give this a distance of 40 inches. 35. Yeah, 32.5 inches. And also make the midpoint and the origin in the same line, that is horizontal. Now you get it. Now this full thing will be, you can't move this again. It will be easier to use this for your chassis design and make this for construction. You can hide the planes also. Yeah. Before I'll get out of the sketch, and I'll do one more thing. I need the same member on the opposite side also. So I'll just select this and mirror it. Yeah, mirror about front plane. Yeah. You'll get a preview. You can just select it. Yes. Now I'll complete this loop by using in the member. Hmm. Get out of the first 3D sketch. Now I'll do another 3D sketch where I'll be joining this lines. This second 3D sketch is only to join this. Yeah. I'll get these both to be equal and give a dimension to this line. Yeah. Now if I get out of the sketch and check it this way, you will be able to see that there is a slight inclination and again decrease in the height. This is for the front axle, for the steering and the front axle. Now get the rest of it done by in the top plane sketching. You'll get this part for the front bumper. This is for the front bumper. Yeah, I'll give this also length 45. Hmm. All the dimensions which I took are just random dimensions. This was just to teach you guys how the basic chassis design is done. Yeah. One more dimension will be the distance between these two. Make sure that if you get this, just cancel. Make sure that you don't want your design to be over defined. It will create a few problems when you try to assemble your design and also while analyzing it, we use an our club uses ANSYS for analyzing. Yeah. Okay. This is the front. This is the bottom part of the chassis. The last part of the chassis will be the firewall. Firewall and also the side bumpers. We'll do it in two separate parts again. We can do the side bumper part in the first design of the chassis itself. We'll go to the first one, edit sketch. You just click on it, you get an option of edit sketch. Edit sketch, draw two members, and member first. This will be 6. Make sure that these both are coincident. Coincident. It is coincident. You can just check it. When you drag two things, you'll get you it see this here. Yeah, now this is not coincident with the line. Since I can drag this point up and down to make sure that it is coincident, you can just click both using control. You need to select both using control and make it coincident. Now it is coincident. Now if you try to move one thing, the whole part, all three of them move at a time. It means they are coincident. When you click this line, you'll be able to see a few more relations also. This is the coincident relation. This is the horizontal line relation. Now we'll define its height. We'll give it 5 inches. We will define this one to be 15. This to be in line with we want the midpoint of this line to be in line with the midpoint of this one, this member. For that, we'll select both the midpoints and make them vertical. And then give them a distance between each other. We'll give them around 7.5. Then the distance from the firewall. This is where the firewall will start. To the side bump, I'll give it around 5 inches again. See, this is the side bumper part. We can start it. We want this to be on the other side also. So we'll just select these parts, whatever we want to be mirrored. We can just mirror this on the other side so that we don't need to draw it again. We'll just select this. Before we mirror it, we'll draw a line from the origin about which we want to mirror. This will be our reference line for the mirroring. We'll make this also construction. Do this. We'll define it. You can randomly define this reference line. It doesn't need to be 10 inches. It can be anything. Sketch, you select these using control. You always in SolidWorks you always select using control. Then mirror them about the reference line. Right. Now you get it on the other side of the chassis also. This will be our side bumper part. This will be our basic chassis. Now the last thing is the firewall. For firewall, we need to get another plane, but it should be inclined at an angle because firewall is not vertical nor horizontal. horizontal also. You know how a firewall is, right? The firewall is inclined at an angle to the vertical. It's a very small angle. We can just take it around 2.5 to 5 degrees. For that, we'll again make a reference plane. References plane. Now, we want it to be, expand the tree, and we want it to be at an angle to the vertical. Right plane is vertical. Top plane, right plane is vertical. Front plane is in the Z direction. It's facing towards you. And the top plane is the horizontal plane, right? We'll use the right plane and you don't sketch on it. You just get a reference plane, use the right plane. Yeah, this is our chassis. We use the right plane. You can always check which plane it is. Then we want this to be inclined at an angle like this, correct? We'll give it an angle of 2 and check it. Second reference will be this line. See, it's slanted. It's a bit slant, correct? I'll give it a more. If I give it 45, you can see the inclination. We don't want our firewall to be so slant, so just give it around 5 degrees. Yeah, we'll give it 5 degrees. You select OK. Now right click on the plane, you can sketch again. Here, here, here. This, this line, and this line, both will be equal. Now we'll give an angle between them. We'll give it around 75 degrees for now. To, to check, you can just press this perpendicular button over here. It will be perpendicular to the plane. Now, as for this line, we'll give this around 20 inches. Now, since we defined the angle, you can't change the height of this. If you did not define the angle, you can always give a height also. Right, from this. You can give, but we'll be defining it using an angle itself. Let it be 75. This is our chest. Now we'll give all the fillets wherever they are required. I'll take a fillet like this. And this and this. I'll give it a 2-inch fillet. This is the function of a fillet. I'll hide the plane. Yeah, this is the function of a fillet. It makes all the sharp edges into a rounded edges. This is useful because in pipes also, when we assemble the chassis, we use bent pipes, right? We bend the pipes and just use this full thing as a single pipe. So we can depict that using fillets. If it was a sharp edge, it look as if it was two different pipes welded together. Now we'll use fillet to show that the pipes are bent, not they are not welded together. Uh, it's all other parts are also supposed to be fillet. This joint is a fillet. Only this line is going to be welded with with this single pipe. That goes same over here, here, here. Here, this is the start of the pipe. This is the point where the pipe starts, and this is the point where it will end. This point. No. This full thing is again a single pipe. Okay. This This is a single pipe. It will go back. It will bend over here and go again till this end. This whole thing will be a single pipe. This will be welded to the chassis again. We now, as for the pipes part, that's all. This is the line sketch. This is the line sketch. Hmm? 1 minute, please. Yeah, sorry, I did a mistake. Looks like I did a mistake here. This full thing, it had to be up. I drew it downwards. See. Since I did this mistake, I'll just mirror it off now again. So that I'll just select all the lines. Just select these. Press mirror, mirror about this line. I'll close the loop and mirror. Yeah, that will be our firewall, not this. I'll make this for construction also. Yeah, this will be our firewall. That was a mistake on my end. Now, as for the pipes part, there are multiple ways to do the pipes part. Our seniors did it using multiple pipes and they assembled it. We won't be doing that way. Uh, mm, yeah, we won't be doing it that way. There is an option in SolidWorks itself which gives you pipes option at once. In under insert, there are weldments. In weldments, there are structural members. These structural members are pipes. There are multiple types. Pipes. Currently, there's only pipes. Not custom. If I go to ANSI, yeah, these are pipes. Different pipes. These are there are I sections. This is an S section. I'll show you what is an S section. See, this is an I section. This is an I section. Then there's mostly our I sections. Looks like. Yeah, but our case, there is no standard pipe for us. We use different pipes, right? So I'll just clear everything. And we make our custom pipes. I mean, we have to design our custom pipe such that they meet our design our actual design in the lab. So we should make our custom pipes, but for now we'll just use a ANSI standard pipe, the pipe of S40, I guess. Yeah, okay, that's true. ANSI inch and clear everything. Let's go with the pipe. Size will be 1 inch. Okay. Yeah, this will be a 1 inch pipe. This one you just need in this tool of using structure in this weldments tool of structural member, you need to go along the loop. You can't start with this loop and go to the next loop at once. You need to take it as a new group. See, this full thing will be a single loop. This is the single loop. This will be a single loop. Then you go to a new group. You can give the other things. Like you can take the all the vertical ones can also be all the horizontal ones also can be a single group. This. Yeah, we'll do it later. Then all the vertical ones again. Yeah, we'll do a small change. Mm. Our second group, we won't add this one because that's a bumper, right? So we'll give it a different dimension. Then you can edit the weldment by right clicking on the weldment itself. You can edit a feature. And in the new group and new group for the firewall now. The plus point of this particular usage of weldments is that see this part. It actually show you don't need to cut them separately. If you had to, if you wanted to assemble each and every pipe, right, you will have to cut them out. You would have to cut them out. You get it? Here, when you use this weldment, the pipes are automatically cut to the required shape, required ends. The fillet, see, the pipes are bent here. You don't get a cut as you get over here, or a sharp turn. Just it's not a bend over here. This is actually a weld, if it is like this. Now, as for the side bumpers part, we'll just open insert. We'll open weldments again, structural member, and we'll just change it to 0.5 and get a group. Okay. This all this ones. New group. We'll select all the members in this also. That's all. This is the basic build of a chassis, including the pipes and the line sketch. If you guys have any doubts, do ask anything. Hello. Okay. Looks like you guys don't have any doubts. If you have any doubts, you can always text in our group. This video is also recorded. If you have any doubts, you can rewatch it. It will be uploaded to the. It will be uploaded. It will be uploaded in the YouTube channel. We'll send you the link also. Yeah. If you want, I will even share the file if you want it. Yeah. That's all in this meet. If you have any doubts, to ask.
Is the meet done? Like, I have a dentist appointment I need to get to.
Yeah. Just 2 minutes.
Okay, no problem.
Yeah, guys. We'll be giving you a small assignment. Just try to draw this and if you did not get the pipes part, you can just leave it. But do try the pipes part also, and try to make a line sketch and send it in the group, right? And as for the wheelbase and the track width, uh, refer from Vinayak's notes as per his he has taught you guys. Okay, any doubts?